Welcome to my channel. In this video we will try to repair this PCB board. It belongs to a overhead garage opener. The mark GBD and the model is Taiman. So we will try to repair this board. Here we have the LED light and here we have the 7-segment display. So we will try to reverse engineer this board. I soldered 2 wires here for the power supply. It functions with the 24 volt AC. And here I soldered 2 wires for the motor. I will use this bulb instead of the motor. So we will try to reverse engineer this board. I powered the board with 24 volt. Here we get the display. When I try to open the door, we hear the click of the relay, and it displays CS, this symbol C and this flipped C. It means that the door is open, but we have no power to the motor. I will try to reverse engineer this board. We will see what is wrong with this board. So if we remove this LED board, daughter board, we can find here 2 relay. They are used to change the direction of the rotation of the motor. So we will begin with them. Here we have 2 relay. Here we have the motor. It's connected to those 2 relay. Of course we have a coil here for this relay and a coil in the other part. So those 2 relay are connected together. We will see this connection goes for the ground or the plus VCC. This is the main filtering capacitor. I will try to test the continuity. We will reverse engineer only the part that we need. So this part goes to the ground. Yes, this part. No, it goes to the positive. This one. This is the positive of the capacitor. So we have here those 2. This is the first relay and this is the second relay. So those are connected together to plus VCC. We'll see the 2 others where they are connected. Maybe they are connected to this MOSFET to vary the intensity of the current flowing to the motor with the pulse with modulation. I will test here. So in this position, those pin. Yes, they are going to this MOSFET. I will check this is this MOSFET is ERF 1010A. So we will see which pin is connected. I will control those 2 pins. those are connected in this position, those are connected to the positive, so I will see those. They are connected to the drain of the MOSFET. So I will use the other pan. Those are connected to the drain of the MOSFET, so we will try to around the MOSFET. This is the gate. Now we will see the MOSFET. The source of the MOSFET is connected maybe to this resistor. It must be connected to the ground, this resistor, and we will do a test. Here we have the ground. Where is the resistor? This one. Yes, it's connected to the ground. So we have here a tiny resistor here, shunt resistor connected to the ground. And here they measure the voltage with the microcontroller to calculate the current. So here we must find the voltage. If the relay are okay, we must find the voltage in the drain here. We can shunt the drain and the source to see if the relay are okay. Now I will measure. We must separate the tangled wire. This is the antenna. So here we have the resistor. Now I will separate this bulb from the power. Now I will power the board, and we will do the test. We will test if there is a voltage here, because one of the relay will activate. If this one is connected here, it will turn in one direction, and if this lead of the motor connected here and the other to the ground, it will rotate in the other direction. So we have here the ground. I will power the board. Here we have the ground, and here we have the shunt resistor. I will switch to the voltage. We will measure on the drain of the MOSFET and the ground. We must see where is the ground first. The ground is connected to this, yes, to this pin. And this pin is connected to the earth. So here we have the ground, and here we have the drain of the MOSFET. Now I will put this lead to the drain and the other one to the ground, and we will activate the remote control. There is a little voltage, not maybe voltage in Now I will activate the, yes, there is 0.5 volt. I did some test before removing the mold. It was fixed to the motor, which was hanging from the roof. I removed this cover and I tested the fuse like this with the continuity test. It was beeping, so the fuse is okay. But look, when we remove the fuse, we test the socket. It's still passing current and the fuse was blown. It figured out that there is something wiring with this board. The fuse is located here. So when the fuse is blown, the current passes from this path. So you must test the fuse out from the socket. But now the motor is not connected. So how the current can't pass from this path? It figured out that there is another component here shorted, and this component is connected here in parallel to the motor. It's like a diode, maybe a TVS. We will remove this component and we will replace the fuse and do a test. This component is in parallel with the motor, because those relays are connected to the positive or to the negative. When the motor is stopped, either those relay or those pins are connected to the positive together or to the negative, to this MOSFET. I will remove this component. I thought it was a diode, but it's not a diode because we can't put a diode here. The direction of the motor changed, so maybe this one is positive and this one is negative, and they are flipped when changing direction. So it may be a TVS to protect the motor from high voltage, maybe. I will remove this component. Maybe at first this component was blown and it blew the fuse. Now I will use a screwdriver to pull the component from the bottom. It's soldered from the two sides. We need a lot of heat to remove this component. It refused to separate from the board. We can add some heat here. Yes, now it's removed. Okay, now it's removed. We see that there is no short there. Now we will test this component out from the board. It's still hot. Yes, it's shorted. And now the short must gone. Okay. The short is gone. We will try to charge all this compound. 5K E 30. I will do a search to find the compound. Yes, it's TVS 5KE 39CE. It's TVS transient voltage suppressor. So this is the problem with this board. The TVS is shorted and the fuse is blown. Now I will replace a new fuse and we will connect the bulb and do a test again. This is a 10 amp fuse with slow, not fast, slow blow. This is the fast. Tip rapid means this is the fast fuse, so I will try to charge another one. Maybe those are slow. Usually we find the letter F means fast. For example, this one. Yes, F. If you find F in the beginning of the reading, that means it is fast. This is 630 milliamps, so this one. Now we will try to search here. I didn't find the 10 amp fuse in my collection of fuse, so I went to the electronic shop. I will now insert 10 amp fuse here. I will solder the wire and we will do a test. We'll solder this load. This bulb will replace the motor. Now the load is soldered. I do have a DC motor from an OLED parabola actuator, but it's in the junk box and it will take a lot of time to search for the motor. So I used this bulb just to test the relay and the MOSFET. Now I will press this button for learning mode. It will indicate LL here. Now I will push here. It stays on, so it's okay. As you can see, now the motor is moving. We come to the end of this video. Thanks for watching and have a nice time.